Today I'm going to be talking about the timeline of atomic models. John Dalton talked about the atomic theory in 1808, and when he talked about the atomic theory, he had four statements about it. The first statement was each element is composed of tiny, indestructible particles called atoms. The second, he said all atoms of a given element have the same mass and other properties that distinguish them from the atoms of other elements. Number 3, atoms combine in simple whole number ratios to form compounds. And finally, the fourth statement was atoms of one element cannot change into atoms of another element. In 1904, J.J. Thomson created the plum pudding model. In this model, there was a sphere, a positive sphere that contained the negative electrons, and the model is called the plum pudding model because in J.J. Thomson's, with his viewpoint, he saw the sphere as the pudding and the electrons as the plums within the pudding. He saw it as just a circle with little dots, you could say, within it. In 1911, Ernest Rutherford's nuclear model was created. For this model, Ernest talked about or created the nuclear theory, which stated that most of the atom's mass and all of its positive charge are contained in the nucleus, and also most of the volume is empty space, and this is where electrons are dispersed, as you can see in the green dots in the picture for this example. And number 3, there are as many electrons outside of the nucleus as there are protons within the nucleus, making atoms neutral. So with there being 2, 4, 6, 7 electrons in the atom, then that means there are going to be 7 protons in the nucleus, which the positive and the negative, with positive 7 protons and negative 7 electrons are going to cancel out and create a neutral charge in an atom. In Niels Bohr's model in 1913, the idea of orbitals was created. So Bohr's model had electrons traveling around the nucleus in circular orbits. The orbits existed at only specific distances, so there were defined electron shells for each atom, and they had specific spots that were standard for each atom, for every atom, and that didn't change. And he called these orbits stationary states since they contain such unexplainable stability. They're very stable orbits. Like I said before, since there were specific distances that didn't change, they became stable. But it wasn't quite explained in 1913. Ernst Schrödinger's quantum mechanical model that he created in the 1920s, you can see that this model changes from having an orbital to having an electron cloud. The electron cloud is around the nucleus in the center, and electrons move within the electron cloud. Electrons do not move around as structurally as they do in Bohr's model, and this is because with electron cloud, electrons can move more freely, and in Bohr's model, with the orbitals, they had the electrons in that model were staying on the specific orbital and didn't move as freely on their own. And with Schrödinger's quantum mechanical model, electrons have a more realistic representation or visual representation in this model because electrons move so freely, it's hard to pinpoint them exactly where they are in an atom. So having them illustrated to be an electron cloud versus an orbital is much easier to understand and see in an illustrative form. The quantum mechanical model with protons and neutrons is the best way to visually represent the atom. James Chadwick discovered neutrons in the nucleus along with protons in 1932. So this final illustration that I'm showing you right now includes many scientists' ideas and inputs into what the atomic model should look like. And with James Chadwick's addition, it gives a final product as to what the nucleus contains. So this model, like it says, includes protons and neutrons in the nucleus and electrons in the electron cloud. I hope you see the progression and how the final atomic model with the quantum mechanical model was created, and how each scientist had their own input over the years to where we could have a realistic visual representation of what the atom looks like. Thank you.